Use the heat-based airflow calculation to nail your furnace or air handler cubic feet per minute by multiplying voltage by amperage by 3.414, then dividing by 1.08 times temperature rise to get a fast, field-accurate cubic feet per minute estimate for heating mode. Grab a clamp meter and thermometer and let us set up cleanly before crunching numbers. Put the system in heating mode at steady state for at least 10 minutes so the temperature rise stabilizes across the heat exchanger. Measure supply air temperature in the main supply trunk at least 12 inches downstream of the plenum, and return air temperature in the return trunk at least 12 inches upstream of the blower, both away from radiant surfaces. Subtract to get temperature rise in degrees Fahrenheit. Measure line voltage at the equipment lugs and blower amperage with other high-load accessories off so readings reflect the current operating condition. For electric heat strips, make sure all stages you want measured are energized. For gas or oil, the electrical input is still used only as a proxy in this simplified method, so confirm burner is running clean and steady. Now, compute sensible heat. Multiply voltage by amperage by 3.414 to estimate British thermal units per hour heat output from electric heat, or to keep consistent with the provided method. Divide that result by 1.08 times temperature rise, where 1.08 equals the density of air times specific heat times minutes per hour, yielding cubic feet per minute. Validate the result against nameplate rated airflow for the equipment tonnage or capacity, then tweak blower speed taps or speed percentages and recheck temperature rise until cubic feet per minute aligns with target. Log ambient conditions, filter condition, duct static pressure, and all readings, so the calculation is reproducible and defensible for service records and quality control. One of the big mistakes in heating, ventilation, and air conditioning airflow testing is measuring temperature rise too close to the heat exchanger or return opening, which gives artificially high or low delta temperature and throws off the cubic feet per minute. Fix it by placing probes 12 to 24 inches away, shielding tips from radiant heat, and averaging 2 or 3 holes across the duct. Another common error in airflow calculation for search engine optimization, keywords like furnace temperature rise formula and airflow cubic feet per minute, is skipping steady state, so the blower ramps and staged heat skew readings. Fix it by waiting 10 to 15 minutes, confirming stage status, and rechecking that temperature rise is stable within 2 degrees Fahrenheit across a 3-minute window. A third frequent issue in calculating airflow using temperature rise is ignoring total external static pressure, leading to the wrong blower speed choice and noise complaints. Fix it by measuring static pressure with a manometer, comparing to manufacturer charts for target cubic feet per minute at that static, then adjusting tap or percentage, and confirming the new cubic feet per minute with the temperature rise formula. BigHomeProjects.com lists vetted heating, ventilation, and air conditioning contractors who can measure airflow with the temperature rise method, perform static pressure diagnostics, and balance duct systems so your system delivers the right cubic feet per minute. Homeowners find trusted local pros with reviews and credentials, while contractors showcase expertise, win qualified leads, and grow business with better visibility in a directory users actually consult when they need real fixes.